In year 6, can you believe this is our last month? This is your last month in year 6, and then after that it's off to secondary school and off to year 7. Can you believe it? I know it's been one of the strangest years ever, definitely one of the strangest years for me, and I'm sure it has been for you, but we made it through, and you've been working hard, you've been disciplined, you've been making sure that you do your lessons and keeping yourself on target, because you know that it's not about anyone else, pushing you and telling you what you need to do. It's about you doing what you know you need to do to keep yourself where you want to be. So we are super proud of you. So keep up the amazing work. Anyway, let's get started on today's lesson. So today is the 1st of July 2020. And I'd like you to write down today's date, the date in Roman numerals, and our learning intention, which is to explore the scale factor. For today's lesson, you'll need your pencil, paper, thinking hats. You'll need the worksheet emailed to you this morning called the scale factor, and you'll need a 5-minute timer. Check. Arithmetic questions. None of these should be too tricky. But just making sure that when you are if you use the written method, making sure that you line them up. Ones under the ones, tens under the tens, decimals under the decimals. So pause the video here and off you go. Brilliant. Let's go through the answers. So for the first one, our answer is 880,990. So you also, as well as using your method hat, you need to make sure you're also putting on your logic hat, which is when we look at it and we think, does that look right? Does it look like it makes sense? Yes, it does, because 600 plus 200, 49,000 plus 31,000, and then using that to help you work it out as well. Does it look like it logically makes sense? Number 2, 908.72 minus 256 minus 61. And to make sure that you've got your decimals under the decimals, and make sure that you subtracted and didn't add. So you would have got 652.11. 532 times 71 is 37,772. 17,426 divided by 2, so that's just halving that number, and we get 8,713. For 2 3/10 minus 3/4, you had to make sure that the denominator was the same. But before you could do that, you also had to make sure that your mixed fraction became an improper fraction. So we would change 2 3/10 into 23/10. So we'd have 23/10 minus 3/4, but then we'd need to make sure that we're using the same denominator, and we know that they both can be, if we multiply 10 by 2, we get 20ths, and if we multiply 4 by 5, we get 20ths. So then once we've made them the same, we'd have 46 over 20 minus 15 over 20, which gives us 31 over 20, and then you could simplify that, so you might have left it as an improper fraction, or you could simplify that to have 1 and 11/20. Okay, so 1 whole and 11/20. There are 20 20ths in a whole, and then that leaves us with 11/20 left. Number 6, 89.02 divided by 10. So we know our numbers are just going to move one space to the right, so that's 8.902. 2 cubed, that means we're doing 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. And 5/7 times 4, well, then we know 4 by itself is the same as 4 over 1. 5 times 4 is 20, and 7 times 1 is 7. So that gives us 20 over 7. And we can simplify that by looking, we know that there are 7 sevens in a whole. That means there are 7 sevenths in a whole, sorry. So that means that there are 14 sevenths in 2 wholes. So that gives us 2 wholes. We can't do 21 sevenths because we've only got 20 sevenths. So 14 sevenths gives us 2, and then we have 6 sevenths left over. So our answer there is 2 and 6 sevenths. If you're unsure of any of those or need help with any of those, then email us and just tell us which questions you found difficult, and we'll be able to. So today we're looking at scale factor, and we need to understand the term enlargement. So if you look at the car shown on screen, you see that the car has been enlarged, keeping everything in proportion. On the enlargement sheet, if on the one that's been enlarged, we can see that even if we go back to the original picture of the car covers 5 squares down and it covers 9 squares across. And it's the same on the enlargement sheet. Although the squares are bigger, it still goes 5 squares down and 9 squares across. We'll see that if we look at the second row and the third box across, then we'll see that there we'll find the wing mirror of the car, and it's the same on the smaller picture. We'll also find that if we go to the first row and we go down to the third box, we'll see the top of the wheel, and that's the same on both pictures. So even though it's been enlarged, they still made sure that it's in proportion to the first picture. So what is scale? Well, a scale is a way of representing real things using ratio. For instance, on a map, you may have a ratio of 1 centimetre to 100 kilometres, where every centimetre on the map represents 100 kilometres in real life. Why do you think we need to use a scale on a map? Pause the video here and speak to someone in your home about why we need to do that. Brilliant. I know, and I know you don't have this either, but I know we don't have a paper big enough for us to be able to draw a map that's 100 kilometres long. Not only that, where would we store it? It's impractical. So instead, we have to be able to scale it down so that we can still represent the distance, we can still represent how far things are in relation to one another, but on a smaller scale. Like if I wanted to draw a picture of the house opposite my house, I don't have a paper big enough for that. So instead, I'd have to scale it down. Okay, I'd have to think about what measurement I could use to represent that house, and then making sure that the distance where I draw the distance from the window to the door is the same as the distance on the actual house. We use scaling, either reduction or enlargement. So reduction is when we're shrinking it, and enlargement is when we're making it bigger, to represent simplified versions of objects and distances. So we've talked a lot about the enlargement side. For the reduction, we've talked a lot about the reduction side of things, but if we were enlarging something, then I might have a small ant, and if I want to draw a picture of the ant, then I would need to draw an enlarged version. So here are some examples of scale factors in real life. A toy car, a microscope, a world map, binoculars, and a doll's house. So all of these are examples of scale factors. When we're drawing a world map, we still need to make sure that the distance from Africa to South America is scaled as it would be in real life. So again, scale factors are important in so many things around us. In rectangle A, the length is 3 squares and the width 2 squares. In rectangle B, the length is 6 squares and the width 4 squares. The width and the length has been doubled, so it's been multiplied by 2. And we call this a scale factor of 2. Okay, so both the same shapes, one has been enlarged, and so it's been doubled. Now let's look at the rhombus shown on screen. So we've got in rhombus A, the measurement AC, so that's the distance between A and C, is 3 squares. And the measurement between B and D is 1 square. In rhombus B, the measurement AC is 6 squares. And the measurement BD, so the distance between B and D, is 2 squares. Each measurement has been doubled, again multiplied by 2. So this also has a scale factor of 2. What scale factor has rectangle A been enlarged by? Pause the video here and write it down. Excellent. Scale factor A has been enlarged by 3, because we can see it has a length of 1 and a width of 3, whereas B has a length of 3 and a width of 9. So it has been enlarged by scale factor 3. What is the enlargement scale factor from square A to square B? So pause the video here and write down your answer. Excellent. So from square A is 2 by 2, whereas square B is 3 by 3. Now 3 isn't a multiple of 2, so we're going to have to look at maybe using a decimal number here to help us find the scale factor. 2 is too big, because that would mean it would have to have a scale factor of 4. And 1 is too small, because then it would be a scale factor of 2 by 2, which is the same as A. So it's halfway between that. It's actually a scale factor of 1.5. It's not a scale factor of 2, it would be too much. It's not a scale factor of 1, it's halfway between the two, it's 3, so it's 1.5. What is the enlargement scale factor from square A to square C? So if you look at A is 2 by 2, and C is 4 by 4. What is the enlargement scale factor? Yeah, this is an easy one. The enlargement scale factor is 2. We've just doubled it, times it by 2. If shape A has been enlarged by scale factor 2, what would the length and width measurements be? So look at shape A, and then look at shape B. Imagine it's been enlarged by scale factor 2. What would the length and width measurements be? Pause the video here and write down your answer. Excellent. So this was just a simple multiplication, multiplying by 2. 90 times 2 gives us 180, and 60 times 2 gives us 120. So the width is 120 and the length is 180. So now let's look at another one together. If the smaller shape has been enlarged by scale factor 2, what are the measurements of the sides of the enlarged shape? So we've been given lots of the measurements of the smaller shape, but not all. So I want you to pause the video here and write down the measurements of the enlarged shape. Excellent. Let's go through the answers. So AB goes from 40 meters to 80 meters because we're multiplying by 2. BC goes from 10 to 20. CD, that one's a bit trickier. We know along the bottom is 40 meters, and we know that small bit at the top is 10 meters. 40 take away 10 gives us 30, so we know the original shape, CD was 30 meters. So on our enlarged shape, the measurement CD would have been 60 meters. So our answer there is 60 meters. Now DE, how will we work out that? Well, on the original shape, we can see AF is the length of this shape, which is 20 meters. And parallel to that, we know that BC was 10 meters. 20 take away 10 gives us 10. So we now know that DE was 10 meters. Meaning, on our enlarged shape, it's going to be double that, which is 20 meters. EF on our original shape was 10 meters, so it's going to be 20 meters on our enlarged shape. And FA was 20 meters on our original shape, so 40 meters on our enlarged shape. Well done if you managed to get those. So what next? You were sent a worksheet this morning, scale factor. I'd like you to have a go at completing the worksheet shown. And remember, looking forward to seeing all your work emailed to us at the email address shown on screen. Have an amazing day. Bye.